All right, hello. I'm going to try to give you some context on what is actually going on with this linear transformation stuff. When you're looking at a linear equation, there are certain different sections of this linear equation. I'm going to try to write it a slightly different way. So let's look at our trig function. So we have y is equal to a sine of x plus b. Well, actually, let me go back. Sine of b times x plus c plus d. Okay, so if we're looking at the x part of this function, the x part of this function is actually this part. So the same number that you see up here would be the same number as this number for your value up there. So what I'm going to do is, if I'm actually looking at the period of something, I'm going to put these two things in parentheses. Okay. When I'm looking at that number, it's telling me how much of a stretch I'm going to have in the x direction. So this is what this means. Both of these two numbers are dealing with the x direction. So if I have my regular sine curve, and these numbers here would be 2 pi, pi, and 0. The regular period is 2 pi. So what this number does is it takes this period and it stretches it out. So you're going to have a stretch in that direction of this function. So let me draw that. I'll do it in blue. Actually, I'll do it in red. So remember our original function, this is 1 and this is -1. And I'm going to extend this line out. So this would be 3 pi and this would be 4 pi. And my original function is still going to start off here, but instead of it crossing or getting at a maximum at a half pi, it's going to make a maximum of pi. And then it would be a point of inflection at 2 pi, and then there would be a minimum at 3 pi, and then it would go back to its original place at 4 pi. So this function now is stretched over that distance. The other thing that happens is you have a phase shift. And that phase shift is going to cause everything to move that direction. I'll do that in a different color. It's going to cause everything to move in that direction, pi. So what I'm going to do is I'm going to take this function and I'm going to slide it back that direction, pi, because this is our c. So that's the same phase shift. So I'm going to pick this function up and I'm going to shift everything that direction, pi. And so that's what those two transformations are. If I look at the y-axis, So let me extend this line back. Oops. This number tells you a vertical stretch. And so that vertical stretch is going to be the same as this A. So instead of it being a maximum of 1 and -1, it's going to be a maximum of three and -3. And so let me redraw that in green. So you're going to start here. You're going to go to the maximum there. You're going to, well, I guess if I was doing this correctly, it would be at a maximum there. And then you're at 0 there. And then you would be at 3 here. And then you would be at 3 pi there. So your function is going to look like that. So that's what that transformation does. It actually expands your maximum and your minimum points. So that's your amplitude there. Because it's -3, it then flips this thing upside down. So let's see here. Let's do that in pink. So there, 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 and there. And so that's what the -3 does. This 1 takes this curve and moves it up 1. So that your median line would be there. And so I'm going to take this curve and I'm going to pick it up and I'm going to move it up 1. And so that pink curve is what your actual answer is. So that's how you go through all the linear transformations. This number affects your period, so that's your B. This number is your phase shift. This number is your amplitude. And this number is your vertical translation. So that's how those different numbers work.